Okay, good afternoon, everybody. I'm Renterghem. I'm going to talk about debugging and profiling scientific code and libraries and scientific libraries. It's the topic of today. I'm going to talk about different kind of debugger mainly, and also some profiler. And I'll explain what's this and how to manage the different versions which are installed on the CC cluster. Tomorrow for the week, tomorrow it's a full day of NPI, so it will be very interesting. Nowadays I present some how to debug NPI code, but I will not enter into details because we don't have seen how to use and what exactly is NPI. So if you want to follow, you can have you can type this URL in your web browser, and you can follow the discussion there. Sometimes I have link, and when I click, I middle click, so I open another tab, so I can come back to the previous and to the slide there. I show you. In the first part of this presentation, I will present you some Intel Cluster Studio stuff. Intel Cluster Studio is a bundle of plenty of HPC tools made by Intel company. Of course, the compiler, we have already seen that. The specific library, mathematical library, which are called matkernel library, and some other tools that are not so commonly used. And nowadays, with the installation of new version every 6 months, we don't install those tools again. So if you want to use it, you have to use another module release, an oldest one, or I've done this for this training session, a small script, which is called Intel Cluster Studio.sh. You can source it, and then you will have this executed. So you will have all the variable and the proper environment to work with, of course, the compiler and the advisor, the inspector, the VTune, and amplifier, which I will present to you, or the high tax at the end. I begin with the first one, which is we have already seen that how to use the compiler, the iFortran, the ICC, the IC++, and so on. But the documentation done by Intel is well done, and I encourage you to have a look to this. I take all the time those small interesting tutorials to show you some specific development done by Intel. What's the MIC architecture? Many integrated core with the Xeon Phi architecture. What's the auto vectorization? So when you compile a code with specific settings, you get information of how the compiler do to optimize and to speed up your code in the loop. For instance, it uses the single instruction and cut the loop into different portions, so they can be done in a vectorization ways, so it's faster and automatically done at level 2 with this as a report to you. You will see them. Even on a higher level, but it's not very efficient all the time, but it exists, and so I will show you that. It's the parallel autoparallelism instruction, and of course you can help the compiler to see, yeah, with guide you take into account the comment I've put in the code in order to parallelize some portion of code. There are still examples there. What's the query Fortran? Query Fortran is a Fortran standard implemented in Fortran 2008, I think, and it works with shared memory and distributed memory. I'll let you install. You're welcome. And then some example of how to use Intel Map kernel libraries. What's in fact, Intel many integrated core architecture? In fact, since 1 or 2 years, Intel stopped every development with this architecture, but that was promising, but it lose the war with GPU, NVIDIA or other company. The idea was great. It's to have PCI cards equipped with plenty of small x86 CPU. So on one card, you have more than 61 CPU, small CPU, but still Intel compatible CPU. And you can see that, and it can be configured as a GPU accelerated card, or even more as a small integrated cluster. So, and with Slurm or whatever, you see 61 CPU upon which you run an MPI program and or parallel execution of code. Of course, there are restrictions. The restriction is that the memory is not shared by the main CPU, not the, and in order to share information between the small CPU, the GPU, the accelerator CPU, and the main CPU, you have to explicitly send data from the main memory to the accelerator memory. And with the compiler, it managed these settings. It's not well used and it's not more used here in CC. We had still 1 year ago one Xeon-Phi card, but due to the fact that nowadays it's all the time GPU, we don't use that anymore. But I still present you because the idea and the concept is still the same for distributed memory and distributed way of making that on the accelerated card. So you put the concept of offload, that means the same code is compiled by the compiler to be compatible with the main CPU and the small accelerated card CPU. And you have extension of Fortran of C code saying that upon which CPU am I running, what's the number of available CPU, and you define portion of code saying that this portion of code must be offload, that means must be on the accelerated card, and with data being seen as from inside the main computer, send to the accelerated card. This is in and out, or just in variable, or just send back value. And so when you compile it with minus offload, it takes that into account. If you said no offload, the result must be the same because it's only a comment and it works. And if you don't have the same result, then you are in trouble. This is what we call the MIC extension provided by Intel compiler. The second small example or tutorial is the auto-vectorization. I can show you there, for instance. I middle click there, I open another tab, and I use the auto-vectorization. And yeah, on Lemaitre tree, if you want to have everything, you can copy this recursively, TMP, to your home. So you will have every exercises. And do that at home or whenever you want with the different tutorial, with the script I show you to set all the environment. This or that we will do that after. And what's now the vectorization sample there. So with the minus vec, it enables vectorization, generating a specific code on Intel, taking into account and this optimization is already done at level 2 or higher, of course. And so when it is able to do that, the loops are vectorized automatically. And you get a report. So in the example, this is, for instance, drive of matrix vector multiplication, a small example. You get a reference with no vectorization, and this is to get the report. And then you see, if you ask for a report, you say that in the column 3 on the specific line there, this loop is vectorized and so on. If they are in a loop, it will say that it's not possible to vectorize this loop because the outer loop is already vectorized. So that's normal. Or sometimes he said that, yeah, I think that it's too small. The problem is too small to automatically vectorize and there will be no gain. So you see, not in a loop, it doesn't make this vectorization of the loop, or possible, but it seemed not to be efficient, so it will pass it. You can also get an optimization by asking for an alignment of data. So the data is aligned to the 16-byte boundary by specifying on this variable. I want, it's a comment in Fortran, but in C, the syntax is quite the same. It's a C comment. Those variable, and then it generates less cache miss between data when it's taken from memory to CPU cache, because we suppose with array, and at every loops, it takes one value from the array after the other. And if it's not well aligned, there are more cache miss, meaning that they lose more CPU cycle to make the same work. And then with -d, this is the preprocessor definition. And if you look inside the the program driver .f90, you will see that if this value is defined in the pre-processing phase, then this portion of code is taken into account with the if-def. It's a common way to specify and to make specific code according to different value defined at the compile time. Sorry. So vectorization, not vectorization, this is what I said. So then next, the third exercise is about autoparallelism. When we specify I want the code to be parallel, we can use the small exercises. I provide you the sources of this. It's a tarball, so you unpack it and you extract it, small Fortran program. And when you compile it with -parallel, you will see that instead of running sequential, it will be multi-threads and running. And yeah, and of course, with guide, it gives you the information where you get. This sample is there. With parallel option, it gives you recommendation for autoparallelization. And of course, the value in the loop must be independent, loop independent, otherwise the parallelism is not correct and the value is affected at the end of the loop. A small example. Give you advice that the T is not independent, and in order to be able to make the parallelism on the loop where T is affected, you have to specify that in the parallel loop, T must be private. That means that every thread has its own T variable, and at the end, the result is correct. Fourth example of improvement done by Intel on the compiler, it's the Core Fortran. It's a standard Fortran, but it's implemented, and it's something like OpenMP. You will see OpenMP training session after next week, I think, or 2 days maybe. The concept is the same. It's when you specify at the compile time that you want Core portion of code where they are Core directive. This portion of code will be parallel. It can be parallel at the portion of code or inside a loop of Core loop parallel. And for the execution, you specify the number of threads, of Core threads you want, Core instance. If you compile that with, I just want 2 threads, your job will be able to run twice if it's optimized for a long time, yeah, for the parallelism. Let's get a look to the sources of this. No. There. Then Hello images is very simple. And you see the basic program, just a little world, and with specific instruction, num images. And when you compile with -array, you see that on 8 threads, I'm the number 1 and the number 2. The order is random, and it depends on when the different jobs start on different core or inside the same core. Not very important. You specify, I just want 2 images, or I set a variable there. I just want 4 or 3. Intel have also different library. Maybe it can be relevant for you, but I just inform you that it exists. If you want to have a look to the integrated performance primitive, it's mainly for MPEG and video compression and manipulation. Threads building block, it's something just like CoArray in Fortran. It's directive, but only in C++ to generate parallel threads, and was just like OpenMP, but OpenMP is more portable because OpenMP is, works on Fortran and C and C++. This thread building block provided by Intel work only on C++. And it's also compilation directive with comment insert in your portion of code, in your sources. The Intel use the GNU debugger, but I will first show you the GNU debugger, and after that I come back to the stuff Intel have had to this debugger, the GNU debugger, to be more specific for his architecture and his features. So Intel extension, for instance, allow to debug in parallel and also detect boundary violation inside array value or things like this. And also the Intel debugger allow you to debug OpenMP, so multithreads code. Even you can debug Intel MPI code, but it's not easy because you have to open as many as window or terminal you want to run and examine the contents of the MPI job, MPI instance. So sometimes it's a little bit tricky to manage that, but I will show you. There are one tool provided by Intel Cluster Studio. As I said, nowadays it's not directly installed, but the previous version from 28 is still available. It's the Advisor. It's a tool, Java tool, very heavy stuff, graphical environment, and maybe it's a little bit difficult to start with an existing program. But when you begin to develop and when you learn this stuff at the same time that you develop your program, it's more easy to manage. The Advisor is a tool helping you to find where are the best place to put your effort on the parallelism, because yeah, generally program it's not only one big loop making all the time the same thing on value. Yes, it exists, but not all the programs are like this. There are plenty of portion of code, subroutine, loops, and so on. And on portion of code, yeah, it's easy to parallel, but it's only passed through one time. So the improvement, the general improvement is not great because this is not so much used comparing to other portion of code. So with this Intel Advisor, it helps you to find the best place where it spend more time and where the insertion of portion of code in parallel will be a great gain for you. Two levels of parallelism at the threads level. So multi-threads, that means a portion of code with call of subroutine and so on. And at the end, there are fence where everything is put together to come back to a C control execution, or vectorization at the loop level, where are the loop that will get a better gain for the vectorization. What are the benefit of reorganize the data inside the loop, for instance? For instance, if inside a loop an operation is done, but it's not necessary to be inserted inside this loop, the best way to improve the code is to put that at the end of the loop or before the loop, depending on the value used inside this. So you get a report, a full report, where are the vectorization, or where are the loop, and they come with suggestion, and of course it counts the number of times subroutine is called, what's the number of floating point operation which is done in portion of code. So what's the number of data bring from memory to the CPU and in and out. The roofline characteristic, that means that when you first run Advisor, it check for the maximum performance it can reach, for the maximum throughput of the data through the memory bandwidth, or what you may expect as the top performances, and then you get a graph and where are your code according to the amount of memory, the size of the cache, and so on. The best way to we can have a look to the Advisor example on the documentation there. But depending on the way you want to search for optimization, you use the vectorization process or the trading process, but it's quite the same, and it's interactive and a loop process to do that. There are portion of an option that is not mandatory. For instance, if you want to check the roofline and the top performance and at which level of optimization is your code comparison to the maximum you can reach. This is not mandatory. This is an optional phase, but when you decide which loop to investigate, you put the parallel and the effort on this, and then you run this process again on your code, And so it's an interactive process to try to reach the best performances. And these tools help you to do that. I think that, yeah, it's a bit oversized, but you must know that it exists. You see, and advisor start with a GUI or with a command line with a click. Both are available. And the example well done and for the training done by Intel is the multiplication of a matrix. I encourage you to have a look in this code. See. There is a make file there. And there are different ways to compile it according to the, if you want to build with debug and so on. It's well done and it's a good exercise. Another tool provided by the Cluster Studio, the Intel Cluster Studio, is the inspector. This inspector is a tool helping you to search for instance, memory leaks or error in memory access. And just like, and I will show you that at the end, it exists also Valgrind, which is an open source tool, not as sophisticated as Inspector, but you can do the same thing with Valgrind. So it helps you to find data conflict, for instance, memory leak or invalid memory access. Bed allocation, disallocation, you allocate plenty of room, but you forget to disallocate it. You will find that directly and say, yeah, there is, at the time, more you run your program, more it takes memory and it's not released. So this is bed mismatch allocation, disallocation. When you define array, but with argument, you are outside the bound of this array. You have, when you use that as a value in the subroutine argument, and you have a mismatch of type or size of the argument, and the value put in the argument that does not fit, or a portion of code which are never reached, unused. So every mistake you can make by working on your own code, and sometimes it's more difficult to find that by yourself. You can all the time try that. Yeah, I failed there. I know the code. I put some print statement and a print value, and I compile it, and I start it, and I see that the value. But with inspector or kind of admin, it do the job for you. And the concept is the same. You choose a project with your sources. You run an analyze, and then you decided. You get the information about where are the error, and you try to fix this error, and you rebuild and you start again until you get an error-free program. So inspector is the Intel version of, if you want, Valkyrie. And again, when you start it with a GUI, you get a graphical environment, but through Wi-Fi connection, maybe sometimes it's a little bit slow. So if you start it right now, it will be a little bit difficult to manage. You will find that not very user-friendly. VTune and Amplifier, it's a couple of programs that work together. VTune is, in fact, just a vampire company by Intel. You link your code with a specific vampire library, and then when you run that, it generates and it collects data and put that into a big file, and with Amplifier you can have a look of what is happening inside the code. So where are the loop, the hot point, that means the portion of code consuming most of the CPU time inside at the source code level, or on the subroutine level. So, and also, of course, the corresponding the portion of code that doesn't use very efficiently the CPU, a lot of CPU cycle lost. Where are the portion of code which should be optimized, and where you put your emphasis for the parallelization. Where spend times, and also where are the input-output operation, which takes time because access to disk or memory is slower than directly work CPU-bound program. The impact of the number of threads, because there is an optimum of number of threads. The gain is not the same if you run 4 threads, 8 threads, 100 threads. The efficiency of the code is not linear. And the bottleneck, the hardware bottleneck, means the maximum throughput and the maximum time for cache miss, time for access from RAM to CPU, and or when it's multi-core, if one core access to a memory through a bus which is not directly linked to the core, the corresponding core. There are different bottlenecks on hardware. You see, when you take, there are plenty of the exercises proposed by Intel is where to find hotspot, and you see with the sample, when you run that, and at the end you execute it, collect it, generate data, and then you see that with Amplifier. Amplifier give you some beautiful screen about the time spent for all portion of code and the time when it's very efficient or when it's not very efficient. And you see, if you have small routing there and you put your effort on trying to it's not so interesting that to put that for instance, on those portion of code. You have timeline visualization tool. You can zoom and see during this time there, you see the process is running, but it's not CPU intensive. There are plenty of wait and communication between different threads. With this tool, you can zoom it and have a very, very short time of view between the different threads. And in the example, I see one MPI application. As I said, in two steps. The first steps, you collect performance data, and the second steps you view the result in the graphical interface of amplifier with amplifier. So there, you say you collect that, you put that into a directory, and you get plenty of same file with a number. It's the process rank of the number. In this example, I have 14 threads, 14 process running there. And with the amplifier grid, you can specify which rank you want to see. And you see with the master and different slave process, the communication between this. If you want a grid report of your own code, and you can get a beautiful screenshot of the communication, the MPI communication between the different threads, the different rank process. It's not a thread. Depends. It's inside the same node, same machine, and then it's multi-threads. But the last tool provided by Intel Cluster Studio is the Truss Analyzer and Collector. Again, it's a profiler, and you see you get with the truss directly the time spent for serial execution, parallel execution, the call of MPI. It's able to manage at the same time MPI and OpenMP program, and you have all this communication between the different. And you see the MPI send and MPI receive. We see that tomorrow, and you see the waiting point when every slave every receive his own data, then it can work, and then the CPU intensive portion. This is in red, the MPI time. The best parallelism is of course when the MPI communication is the smallest, and the calculation of all the MPI process are the best for the efficiency of the MPI code. So you see timeline scene, communication, size of the data sent from one MPI process to another one. This is a great tool. But sometimes, yeah, you see when you have plenty of MPI process, the communication, they become very, very confusing and very not clear. They are linking everywhere. There are communication between everything. But for your problem, put just one master, for instance, and two slave, and if it will be more interesting to see what's the communication between them. Small example with four MPI process, and then it generates a truss file, and with VTune you can have a look. Those are the different Intel Visual Studio tools, but there is also open sources tools. The advantage is that you can have it on your own Linux box and work everywhere with that. You can install the GNU Debugger, or it's by default installed on a machine. And there are graphical environment to work, and it's more convenient and it's more user-friendly. It's the DDD, Dynamic Display Debugger. When you have a code and there are bad behavior, for instance, you have a segmentation fault, or the value is not correct, and there something wrong with your code, you can search, as I said, by putting print everywhere and saying where it begins to fail. But it's not very user-friendly. It's not very easy to do that. But with a debugger, you compile it with a -G option. And the code generated include the sources with the corresponding with the machine code and the source. And with the debugger, you set stop when you start, and then go step by step inside your code, and then you can print value of the variable at every point, go inside subroutine, or just run the subroutine and come back to the main line of code, and then print value, or you can set value different than the one which is seen when you print it, and try if it's the main reason why the code fail or things like this. But the debugger is it's not all the time the solution, because there are code which fail at a certain level of optimization. But when we use a debugger, they suggest you to avoid too strong optimization. Otherwise, the structure of the code can be changed. For instance, loop can be split into different portions, or subroutine can be inlined inside directly the code to be more efficient than instead of jumping with a concept with a stack. Of course, context switching from the one subroutine back to the main program. So there are code which fail, but when you decided to run with -G and -01, there is no failure. So you have no way to use the debugger with no optimization. So it's a little bit annoying, this. I have small exercises inside the DDB. You can copy that from Lemaitre 3, with plenty of code. It's inside tmpdd. So copy DDD and the contents to your home, then you can work with that. When you compile a code, for instance, crash First C++ example, very basic. You see, I decided to compile it. Program called crash. It's not very, and then floating point exception. I have to search why. It's very easy. You can find that directly, but the main idea of this exercise is to use DDB or GDB if you prefer a command line instruction, but DDB. Normally, when I run program, I generate a cordon when there are an error, except when the size of my core of the core is put to 0. I ask for unlimited. Sorry. Then if I execute it, I get a cordon. What's a cordon? It's all the data and the program, the machine code program, put into a package, a core, and that can be examined by the debugger or with, I've lost. Okay. Oh, sorry. DDB, you see, when you start it, well, I don't have all the fonts. It's not. Change the sign. Where can I put that? You see that it's in fact a GDB command line with a way to do that with a GUI. It's the same. So I open a program. Where is it? Program. Hold on. Just working, but not here. Or you can open sources there, for instance. It's crash.cc. And well, return. I started. Whatever. And started directly like this, and then a cordon to be sure, corresponding cordon. You know what we call that a bug? No? Because the first computer was a lamp computer, and there are real bugs which were burned and make the lamp explode, and they have to search for bug inside computer. Real bug. So he said that the core was generated, and he said that the arithmetic exception and this is the way to manage your program. You can run or to put a break where, of course, I don't have compile it with -G, or yes, I don't remember. In order to be, the sources must be included into the you see the size of the program, and then I compile it. It's bigger, but of course, this is, maybe I can change it. No, that's the, sorry, don't play, don't want to lose time. All right, to run it. Well, but now I can view the source normally. Source window, right? Where is that? I can run it there. Or tip there, it's the same. What's wrong? TDB must be ready. It's waiting for what? You know what? You can play with that at home, but when I'm in my office with a 1 GB link, it works, but here with the Wi-Fi, it's not properly well. But never mind. You run it with GDB, you can run it that. You get the floating point exception. You can list it, and you get the sources. And you go, you print where you are, and you print value of X. And of course, what you get X. And you see this is the main reason why there is a floating point operation, because the value of B is from I there, which is 0, and it's not low. And then we make, of course, a floating point exception. First example, very basic, was GDB. You have the problem when you start GDB, you get the hand back, or not? It's ready. Open program. This is something strange. It's waiting for something, I don't know. source window is open. Normally it's seen. Okay, second example is the crash 2. Try to compile it with C++, with the -G option, and try to run it inside DDD, the debugger, or with GDB if you prefer, with the command line. It's the same. Okay, but I see something there. It's printed 10. What about me? Run it. When I run it, I see segmentation violation, and I see the line where it failed. See, when I want to print then put a breakpoint, break, or like this, or B, just a short name, at the main program. And check the list there, the program there. I run it. Start from the beginning, yes. And then it reached the breakpoint and it stopped. Then I next. So I just run one line. Next. And I see the 10, the value printed there. Then instead of next, I want to go inside a setInt. So I use step instead of next. And I go inside setInt with the argument there. And I can print the value of IP. And I see this. Or the value, the pointer on the contents of the pointer. And this is, of course, a bad access to the memory. Because you see in the sources that the value of this pointer was never initialized, and that that means that it reaches a random portion of memory and you have to initialize the value of the pointer, otherwise it at the end, when it reaches the end of the program crash, and this is why at the end you get a crash. There. So the example you can use with DDD or GTP is the program called segfault. Normally this is this. New. Since the version 10, it's clever enough. Default compiler. It's a by default. Red Hat comes with an old version of GCC, but if I have a module loaded from this release, I get a newer and version 10 GCC, which is clever enough to discover that the malloc will be wrong. So I use the default GCC. And then it didn't crash. Oh yeah, because I have a big memory machine. It's quite big enough. Oh, 32, of course. Okay, too big machine, so it works. That's great. Again, it's big enough. In this example, I wanted to show you the problem of the malloc, and when a malloc fails, it returns a zero value. So when you code with malloc construction, never forget to check if the result is 1 or 0, if the condition is reached, if the malloc is succeeded. In this case, when the malloc failed, it gives 0 as and then the program failed. With a segmentation violation. Because one left shifted 31 times, that means that more than 4 GB and 4 GB sometimes it depends on the kind of CPU and on the restriction per user, but it's quite big. And so the malloc is failing. So never forget to check if malloc is succeeded in your C program. Fourth example is the infinite loop. So get from the keyboard, from the sender input, a character, and then write it. And at the end, if it's a number, give the hand back. You think it seems to be okay. So you try to compile it. C minus G, because we know that it will fail. And when you execute it, hello. Oof. Then you have to search why. So you debug your program with GDB. And for that, you put a breakpoint and you go step by step. If you run it, you can control C. Oh, first install. Yes. And you see, I've interrupted, and I can backtrace it or print the stack. The stack contains. Okay. Sorry, and you see the level of stack is from 0 to 5, and this is inside a C library, which is not. And I want to get information from the main program, the user program, not the C subroutine or the C library there. So I go to the frame 5 there, and then I see I can print. I see the H, of course. H is the first in the loop. And I can put the break and go next, next, next. Or due to the fact that it's already next. You see that you are inside a loop because the end of file is never reached there. If you run step by step, you come back all the time by the print C value, which is in my case was H. If you uncommand this, you go this, go through this, and it asks again for a character to the standard input. And then you are able to put something else than a H, for instance, a 0, 1, 2, 3, and then the condition to leave is reached, and you get out. This is the condition to leave the if loop, the if condition. I was talking about the Intel addendum and improvement of the new debugger. It's the Intel debugger with Intel extension. Of course, it supports just like GDB, C++, C, Fortran. You can examine machine code. You can debug multi-thread application, MIC architecture. This is specific to the Intel debugger. You have a small example there. You compile it with -G, just like GDB. And you can specify, I want to debug in parallel. And thanks to that, you can debug multi-thread access and that access to memory when the different threads overlap the portion of memory code or better synchronization. In the file I give, there is a PDF user guide provided by Intel there, and the number of lines talking about the Intel debug parallel addendum are there. Debug data race condition specific to Intel debugger. Where is that? 32. So, but I'm not there. The page is not the same. Where is it? No, sorry. GDB pointer is there, and I want to debug parallel GDB. No, this is the only one I have. Never mind. I'll look at this. This is a bit parallel. And the other is with a check pointer, you detect a boundary violation. There. The number of lines. See, the documentation is quite long and complete. Where is the specific GDB command and then the architecture? Okay. Raise condition, yes, this is what I want to show. And after the filter, never mind, the main important things to remain is that it exists also a specific GDB optimized by Intel with specific Intel instruction. Okay, so I think that with the debugger, I've seen all the exercises I wanted to show you. Maybe you can try and play with GDD on your own code and try to run it step by step to be familiar with the breakpoint, to add or remove breakpoint with DDD, which is more convenient. And just like usual, if you have any trouble with your code, and you don't understand why it failed or where, or you want to try to profile it, we are there to help you and to support you for your own specific code. Don't hesitate to contact us.